Hi, my name is Sharon. I'm the Senior Manager for Maths and Science here at OpenWisdom Education. And today we'll be going through 3 multiple choice questions from the 2020 2-unit HSC. So we'll be going through question 8, question 9, and question 10, which is notoriously the 3 hardest multiple choice questions in the paper. But we'll begin first with question 8. So this is question 8, and it touches on principles of calculus and mainly derivatives. So feel free to pause this video to take a picture of this question or record this question down on a blank piece of paper, and we'll get started shortly. So let's begin by just reading through this question. So they've given us a graph of y equals to fx, and they want us to determine which of the following inequalities is correct. So we can see in all of these inequalities, they're all related to the derivatives, right? So first derivative, we can see first derivative, we can see the second derivative, and we can also see just normal substitution into the function. So because we know we're going to be dealing with derivatives, let's first begin with what the first derivative and the second derivative mean. So just remember, the first derivative tells us whether a curve is increasing or decreasing. And sometimes, of course, or stationary. Okay, so if a curve is increasing, your derivative should be greater than 0. If a curve is decreasing, your derivative should be less than 0. And if your curve is stationary, the derivative should be equal to 0. And then for the second derivative tells us concavity. So whether my curve is concave up or concave down. So if it's concave up, the second derivative is going to be positive. And if it's concave down, the second derivative will be negative. And then equals to 0 will generally be an inflection point. So let's look at this question and see what we can determine for the first derivative and the second derivative. So we can see all of these inequalities are related to the value of 1, or the x value of 1. So we are interested in what does this curve look like when x is 1. So when x is 1, we can see that this curve is, first and foremost, it is increasing, right? Another way you can tell whether a curve is increasing or decreasing is to draw a tangent. So at 1, my tangent looks somewhat like this. And we can clearly see that this tangent has a positive gradient, right? It's going upwards. Hence, we know that at 1, the first derivative should be positive. So at x equals to 1, this means that f-1 needs to be greater than 0. So we know that. Now let's look at the second derivative. So remember I said previously, the second derivative tells me whether my curve is concave up or concave down. So we can clearly see at x equals to 1, this curve is concave down. And how we know it's concave down is you can see it's kind of facing downwards. So remember, concave up looks like this, and concave down looks like this. So we can see that this curve at x equals to 1 looks more like the second version, which means that f-1, or the second derivative at 1, this should be less than 0. You can see here, concave down is less than 0. Increasing would be greater than 0. Okay. So we have these 2 inequalities, and now we can see in these inequalities in my multiple choice options, we also have the value of 0 and also the f of 1 value. So based on this, we can tentatively order the these 3 options. So we have 0, we have f-1, we have f-1, and we have f of 1, right? So The smallest number, I'm just going to order it as 1. So the smallest number right now that we can tell is the second derivative, because the second derivative is negative. So I'm just going to say number 1 for this one. So number 1 means the smallest. And then the next one that we can currently identify is 0, which is the second smallest, because remember f-1 is positive, which means that it must be greater than 0, which means that right now this is the order that we have. Okay, so when we look at this, if I just write this down as an inequality, this would mean this inequality here. So based on that, we can eliminate, let's see, what can we eliminate? We can eliminate C, and we can also eliminate D. Now, we can't eliminate A or B, because if you look for A, we have f'1 is less than 0, which is less than f'1. So this part completely matches with this. But also for B, f'1 is less than 0. And although the next term is f(1), we don't know where f(1) is right now. So this second option also fits with this inequality here, because this inequality is also reflected in this second one here, where second derivative is the smallest, then followed by 0, and then it's followed by the first derivative. So now we can see that in order to decide whether it's A or B, we just need to decide the order of f'1 and f(1). So we need to decide the order of f'1 and f(1). So in other words, which one is smaller, okay? So if we look at f(1), f(1) would just be the corresponding y value. Yeah, and f'1, now I previously said that f'1 is positive, right? But we don't actually know the value of f'1. So based on this, remember the first derivative of a line also corresponds to the gradient of the tangent. And so the gradient of the tangent is essentially the gradient of this straight line here. Now remember, gradient is just rise over run. And if we look at this line here, we can clearly see that the rise over run for this expression is going to be less than 1, because the rise is much smaller, or well, not much smaller, but it is visibly smaller than the run. So we know that f'1 is most likely going to be less than 1. Now looking at f(1), we can see, as I mentioned previously, f(1) would just be the corresponding y coordinate for x equals to 1. And we can see that the y value is larger than the x value, and the x value is 1, which means that f(1) is going to be greater than 1. So because of this, which one is actually smaller? Well, f'1 is smaller. So because f'1 is smaller, that means that the last term in my inequality is going to be f(1). And as a result, the answer is A.